class, but in class, it happened for this particular example, for the point of 0, and I try to simplify to be at the center, all right, to be along this line. You remember what I did in class? We found, you see what I'm doing here? It was along this line in class. However, let me remove that. In the most general case, now let me ask you the following question. Do you know if there is going to be a point where the field is going to go to 0? Are you sure there's going to be a point where the field is going to go to 0?
Yes.
Yes. Why is that?
Because the force from the charge and the rate distance from it change depending on where it's placed, and they should be able to cancel out.
Yes. So regardless of the charges, that whether it is all the same, whether they are different, if all of the charges have the same, which is all of these problems that I gave you, they are always the same concept. If you have charges that have the same polarity, somewhere in the space in between these charges, the field is going to go to 0. That is for sure. I don't know how else to tell you. So there is always that solution. So the question, obviously, that we have to ask is how we're going to get there, all right? Not whether it exists, but how we are going to get there. The reason I'm saying that is in this problem, obviously, the point of 0 is not at the center. And that has to do with the relative location of the charges and the relative values, all right? However, because of symmetry, if it's off center, so if the point, say, is here somewhere, then it's going to be from symmetry another point there. So it does not have to be only one point. As a matter of fact, the more charges you have, the more points of 0 force. So for example, if you have a whole sphere of charges, then, and the charges are the same everywhere on the sphere, then all inside the sphere, the field is 0. We'll see that later. So at this point, you know that at least 1 point, at least there is at a minimum 1 point. There may be more than one. So, but as I said in my email, I don't care about you giving me the whole solution. I just want to see how you set up the problem even for one. So here is what I've done. Here I've said, okay, let's assume that the point, and I will write also, okay.
I'm sorry, can I ask something? Why is it not in the center?
It's, well, you can try it and you will find out. I mean, if you assume that it is in the center, which is it's a reasonable assumption to make. And why is that? Because it's symmetrical, right? So it is true that if you don't know exactly where it is, and if you assume it is in the center, and if you solve the problem the same way I did for the center in class, and then you try to solve, you try to plot this equation to see whether it goes to 0. If you don't find any point where it makes it 0, then it assumes that it's off center. And why it is off center, it has to do with the distance between the charges and the value of the charges. So for example, if all of the charges had the same value, regardless of their distances, then it would have been on the center. If they had the same distance among themselves, it would have been on the center. But because they don't have the same distance among themselves, all right, A and B are in a longer distance than A and C and B and C. And because A and B have different charges from C, it is possible to be somewhere else. But because it's symmetry, this axis here is an axis of symmetry, then if you find it somewhere else, say at O, it's going to be then another point in the other, which is going to also have a 0. See what I'm saying?
Yes. Thank
Okay.
you.
Thank you. All right, so let me now. So now I'm assuming that it's at a generic point O. If it happens to be at the center, you're going to find, and okay, let me take it one step at a time. So I'm going at point O. If I don't know where this point is, then immediately I assign to it 2 coordinates, the x coordinate, which is this one. All right, that's my x coordinate for O. It's x sub O. All right, and the y coordinate, which is y sub O. You see those? I have to find these 2. I have to find the values of these 2 coordinates for that point. But at this moment, they are not known to me. Okay. So I assign those values here. And then I put at that point, I connect this point with A, which is the green here, A. All right, I connect O to A. Then I connect O to B, O to B. And then I connect O to C. And then from there, I draw the field E sub B. All right, I draw, let me in fact use that. I draw this field E sub B, which is the field, the force rather, or the field, all right? In fact, I put fields, but in reality are forces too. Okay, do you agree with me? That if I make those fields 0, the force is gonna be 0. Do you agree? Do you agree with the statement that when I say 0 force, it implies 0 field?
Yes.
Yes, why is that? Who's gonna tell me?
Because that's when all the points in the field are overlapping to become 0. Like you'll have negative values, positive values, and they add up to be 0.
Yes, and why is it when that the field is 0, the force is 0?
It's because the field's telling you at that specific point what the force, the net force is in the direction, and you have 0 field, so it's 0 force.
Is 0 field, and what is the equation that tells us that? Force.
The force is equal to the 2 charges over the vector between them.
Yes. So the total force at point O is going to be the charge, which is -1. You remember I gave you that, times the total field there. So if the total field is 0, the total force is 0. All right. It's this particular equation that makes us say that. Okay. So practically, I'm going to show that the forces and the fields practically, either one you can work on. All right. So now I will remove, since we said that, let me just, I will keep this here. All right, since this is useful. And therefore, we assume, okay, we assume at this point that F or E, total equals 0 at point O. At point O. All right, which also implies, well, we'll see what that implies in terms of equation, but before we go there, I assume that this point O has 2 sets of coordinates, x naught and y naught. And do you see what I have done? When I come, so do you understand why I have gone from a 3D problem to a 2D? Our initial charges were in 3 dimensions. Why am I working on 2 dimensions? Who is going to tell me?
Is it because it's all on the same plane?
Yes. And why they are all on the same plane?
Just because it's 3-point charges and they make up a plane?
Exactly. Every 3 points, which are distinctly different, 3 independent points, make a plane. Every time, any moment, all right? So, not 2 points, 2 points make a line. So, 1 point is 1 point, 2 points make a line, 3 points make a plane. Okay. So, I am working on the plane because I know that is in that space where I'm going to find this point. If I go out of this space, then I'm not going to find it, because out of that space, there are going to be, all of the forces will tend to go into the same direction. All right, if you draw them, I mean, you can draw them, go out of this space, put all of them on one plane and then go off plane, and you will see that all of the forces will go in the same direction. So there is no way that those forces can cancel, all right? Okay, so these are the fundamentals that they are very basic and very important though, because that's the only way to solve this problem, to understand it. And you remember what we said in class. This is my key issue here. I don't want you to learn how to solve an equation, go into the computer and solve it. And as you will see here, I mean, I will not even do it myself on paper. But however, I want you to set it up. This is the important thing. And you're not going to set it up unless you understand the physics behind it. Okay. So now, and a little bit of geometry, obviously. All right. So now I have set this point. What do I need to do next? After, so this is part one. You have to be very methodical when you set up a point, because, and I make a lot of times that mistake too. When I start, when I'm in a hurry and I put equations left and right, I always make a mistake, all right? Because it's so difficult to keep track of the order. So I would say always try to be very methodical when you solve problems so you don't make mistakes. Part 2 now. After we set the point, what are we going to do? Find all the forces, or on the, or like fields here, at that point, at point O. At point O. Okay, that is the next step. So now I'm going to start with EA. You see EA? EA is the green one. EA is, oops, okay. I think that I moved that one. Okay, EA is this one. Okay, so I'm writing. And I'm gonna keep the color so you don't, the colors are important for you so you can follow it, all right? That's why I'm using multiple colors, because it helps you do that when you can, because it helps you see things visually also. Otherwise can be also confusing. So EA here is the field that is due to charge QA. So how are we gonna write this field? And you remember I'm gonna not have a direction at this point, because the direction I have shown it here for a moment. I will, if I were to write a direction for this, and I will write it like that, if you remember. All right. I'm not going to show it, it's going to get complex. And then eventually, because we're going to get rid of directions, obviously, and you will see. But at this point, it's going to be that QA, all right, over 4 pi epsilon naught. And then what is going to be? I'm going to write it in this form, OA vector. And as a matter of fact, if I write that vector here, I don't need to worry about that. And then is the magnitude of OA. But 3 here, not 2. You remember that formula that we wrote in class? So now this is why it's very useful to have that formula, because I don't have to worry about the unit vector and then complicate things. I only have the vector OA. You see the vector OA? Okay. In fact, to be also correct in my writing here, I will have the vector A starts at A, goes to O. All right. In fact, in this particular case, I don't show that it should have been the forces should have been the other direction. I will solve it. Let's assume that this is for a moment 1. The solution is the same thing, whether it's 1 or plus, but minus or plus. But in this solution I'm doing, because I have put the arrows here, I don't want to change them, is for a positive charge Q. So I have to tell you that, all right? Because they go out. If it's a positive charge Q, the vectors are gonna go out. If it's a negative charge Q, the vectors will show in the opposite direction, all right? So if it were a negative charge, the vector will show like that. Do you agree? If Q were a negative charge here, it would show the other direction, but if it were a negative charge, because it would be an attractive force between a positive charge at A and a negative charge at O. But here in my solution, I will use a positive charge, okay? Positive charge. So I have, so it's gonna be difficult to change now those directions for a moment. All right, so we have this charge there. And the right way to write it is from A to O. That's the direction, all right? You see also the direction is important in vectors here. So from A to O. All right? Is that clear so far? Yes or no?
Yes.
Okay. Now, before I do anything, maybe I can write all of the fields like this, and then we will go back and do the rest of the work. Let me then write all of the fields like that. So then field B is going to be EB QB 4 pi epsilon naught, and then it is BO vector, and underneath is BO magnitude to the third. All right, and then we have C, the field from charge C at point O, all of those, which is Q sub C 4 pi epsilon naught, and then is CO of CO magnitude cube. And what we want to do, we want then to write the equation at O that all of these 3 fields, when you add them up, give 0. All right. Now, what would you do if you were to write this equation, but without the vectors? So let me do the following. I don't know whether this is a figure I got. I cannot change that figure, but let's look at this one. Visualize the 3 forces here, E sub A, E sub B, and E sub C. And then they all apply to point O. And then we want to make them at that point 0. So if I had, so that's part 3 now. In part 3, we are going to work with this equation. So part 3. So let's assume equation 1. So what are we going to now think? I am at point O, and I have 3 vectors. So remember that I am in a Cartesian coordinate system, and this is X prime and Y prime. All right, so 1 second. X prime, y prime. I'm trying to simplify from all the other lines. And here on this point, you have 1/4 that goes like, well, let's take it a little further down this point. Let me see where it is. Yeah, here. 1/4 that goes like that. All right, you have, this is A, this is B, and this is C. We'll go back to the original figure, but I wanted to show you here clearly something, B and C. All right, so, and then this is this is then the other, and then this goes like this one. Okay, it's not exactly the same way we had it, but I wanted to point out to how you put some vectors together. All right. Maybe one more thing. Let me change that the direction because it seems to be like, okay, let me assume that this is now here, the other point. Oh, again, let's see. And then we have this one. All right. Now, how are we going to write equation 1? I want to reduce it from a vector form to a scalar form. So I'm going to translate my coordinate system here. All right, so this one is parallel to x prime, and this is parallel to y prime. All right, so here I have the following. Remember that this line continues, this line here continues along that vector. This line here is along this one. But let me start with one vector. So let me for a second eliminate these other vectors and only keep this one, all right, for a second. And say, okay, now I want to, instead of having too many directions, since I have the XY system, I want to express this vector into an X and Y. And as a matter of fact, equation 1 can be written in this form, since for this equation to apply, EX has two components. EA, excuse me, has two components, an X component plus, or EX, how I write it, this is a unit vector, plus a Y component, EY, all right? This is vector EA. So practically, I can write it here. So you write it, that this is vector EA. And then you can write vector EB like that. EBX, EX plus EBY, EY. And then you can write vector C like that. And that is how you write the vectors in a coordinate system. So, and this, yeah, for our here, let's not having the I will eliminate those, so otherwise I don't want to have too many tones, you know, to put that. So it's going to be CX, EX plus CY, EY. Okay. And then if I sum them up from 1, then I can show that I can group all together the x's, the x components, and then I can group together the y components. And then what do I have? EAX plus EBX plus ECX, and these are all of the x components, plus EAY plus E by plus E cy, and these are the y components. All right? And the sum of the three, this is the sum of the three vectors. What does that sum have to be? 0. So from here, that has to be 0, which means that we have a vector with x and y components. So as a matter of fact, if you want to have them on one line, it's like here. All right. And so when is this vector equal to 0? When the x component is 0 and the y component is 0. Do you agree with that? Can this vector be 0 if one of the components is not 0? Who is going to talk?
No, it can't. And I agree that both components would have to be 0 for the overall to be 0.
Excellent. So this one then, the ECX has to be 0, or EBY has to be 0. As a matter of fact, for this simple problem, if one is 0, the other is going to be 0. If you force one to be 0, you will see that the other also will be 0 for this simple problem. Not necessarily always true, but these two conditions are important. All right, so let's try to put all of this. Now I'm looking at this. Let's start with this one. You can start with either one, in fact, but I'm going to use that one for in my solution. You can practice if you want with the other one to see what you're going to get. But because of the way I have put the angles in the original problem, I will start with this one. So now I'm taking equation 2. And I'm going to try to take equation 2 and look at the figure I have, all right, here. So what I will do is take this figure and also copy it and go a little further down because I don't want to go back and forth, paste. So now I'm going to have this figure. And then that was part 3. So I'm going to part 4. Now I'm setting my equation, see, part 4. Okay, so now I will have to find the y components, all right? So I will have practically to take the y-axis that goes through 0. And on this axis, obviously it's parallel to y prime. And on this axis, find all of the y components of the 3 fields. Okay? So the question is, how do we do that? So if I were to go back here, how would you find this is EA for our, so this is EA. All right, and then if you can see the figure that I have, on the figure I have, I called it B, that's okay. Forget, did I say B? I have to make sure that I don't change the, here. This is B, this is A. Okay, and this is C. So this is your EB. And here I have on the figure identified the angle phi B. Do you see the phi B is here, this one? All right, so phi B. Why is this important to me? Because I need this angle to be able to find the component of VB, which is along the y-axis. So you're going to find this component here, which I call the EBY. All right, I want to find this component. From geometry, this here is equal with that one. Do you agree? Do you know why? Who is going to speak? If you don't speak, I will assume you don't know that. Is that true?
Yes, that's
There
true.
were,
What
there
is
were a few people in the comments that said they did know.
Do you guys know or you don't know?
Aren't the angles just complementary because they're across from each other?
They're not complementary, they are identical. So
Right.
when you have, all right, they are different. Complementary are the ones who give you 180 degrees. So like this angle and this one. But this here is equal with this one. All right, always. Phi and phi. But if this is phi, this is gonna be 180 minus phi. If these are the fundamentals of geometry. That's why I'm saying that you have to really, if you have difficulty remembering that, you have to spend a few hours reviewing it. Absolutely critical, because those who don't remember these are fundamental high school concepts. But if we don't remember it for this class, it's gonna be very hard to go through it. Okay, and if this is phi, how much is this?
90 minus phi.
Exactly. Okay, these are important. So what I said here is now that to find EBY, which I will do it here, and you can see for part 4, I want to find all of the Y components. I start with the EB to find EBY, and then that is going to be the same for all of the other ones with the appropriate angles. So EBY, how much is EBY? Who is going to tell me now? Looking at this figure and looking at F, phi sub B, EB, how much is EBY in terms of the magnitude of EB? Who is going to tell me? So it's the magnitude of EB, but what is going to be in front of it?
Cotangent phi b. Or
Tangent? No.
secant.
It's cosine.
Cosine. Cosine of EB. Cosine phi b EB. Okay? That's what it is. Cosine phi b EB. All right? Okay. Now,
I'm sorry, real quick.
yes.
So in the case of the homework where the charge is negative and therefore B we pushing towards B, would
Mhm.
it be negative cosine phi B because it's going the other way and therefore you would be
No, it's
comparing
gonna
it to
be
the negative component of Y?
It's gonna be the same because I will draw it. If it were to be negative, EB, let me use another color, a darker. EB is gonna be like that. You agree?
Yes.
And then EBY would have been down here. So it would be the same thing. It would have been the same thing, but in the opposite direction. Now, usually you see here, this is a scalar form. This one does not have directions anymore. So as long as I have correct directions and correct angles defined for my problem, I don't have to worry about if since all of the forces have positive in this one, you know, yes, for a positive Q, little q, is going to be what I showed in the beginning. For a negative, it's going to be that, but it's going to still be the same function here. It's not going to change the sign.
Okay, thank you very much.
You're welcome. Okay, let me erase that so we don't get confused here for a second. All right. Now, the second one, so I found EBY, all right? And EBY had this as phi sub B above. Now, I'm trying to forget about EBY and go to EA, all right? So What is the angle that I have found for EA is this one, which is this one. All right, that's phi sub A also. Okay. And how much is gonna be E B A? How much is that gonna be? Who is gonna tell me? EBA, excuse me, BA, EAY, I don't know what I'm talking about, EAY, which is, now look at EA, EA is this one.
It's just
here.
gonna be cosine of the magnitude of EA, right?
Cosine what angle?
Cosine 5A.
Exactly,
EA, sorry.
exactly. And then it's gonna be EA magnitude, okay? And now that we've done that, let's go to E sub C. E sub C, which is this one. Look at that I have found. I have defined phi sub C, blue. I have defined phi sub C here. And that is the same with this one. You see? So if I call that phi sub C, E sub C Y is gonna be cosine phi sub C E magnitude sub C. Do you agree?
Yes.
Okay, perfect. So now, with that in place, the next thing that I have to do is to write the cosines of these angles in terms of X naught and Y naught, and the magnitudes of the three fields in terms of the Q's and the distances, X naught and Y naught preferably. Okay, so now that's gonna be part B. So in part B, first of all, I'll start with the angles, part B. Okay, cosine phi sub B. So let me erase this for a second. Phi sub B is this angle that I have here, the purple one. All right, here, purple one, rather. Okay, look at this triangle. How much in this triangle is cosine phi sub B? Cosine phi sub B, is it not this divided? So let me erase some of these colors. Erase. All right. Isn't cosine phi sub B this divided by that in the triangle? Is that true?
No, that's not true.
Okay, which one is that?
It's the vertical line and.
Perfect.
and the
Excellent.
hypotenuse.
Thank you so much.
I was questioning everything I knew in that minute.
See, that's why I'm going to ask you some questions like that, but that's okay. That's all right. This is the process to learn, all right? Yes, I know if I ask you a question with confidence, all right, in my voice about something else, yes, I can see how you are going to question it. But thank you for paying attention to what I was saying. So it's Y naught, all right? And then how much is OB? OB is gonna be, I will write it, square root of x naught square plus y naught square. Is that true? Because in this triangle, the diagonal, which is this square, is equal to that square plus this square. All right? We have that OB square in this triangle is x naught square plus y naught square. Is that true?
Yes, that's true.
Perfect. And then if I did not want to skip a thing, I will say here that's y naught over BO. All right, which is y naught over square root of x naught plus y naught square, each one of them. Okay, found that. Now that I found that, I will try to do the same thing with all of the other angles. All right. Tell me how much is cosine phi sub A? Think it through.
So the cosine of phi A, what did it be again? YO
Yes,
over, in this case, AO, which
Yes.
would be square root of, uh, would it be the same thing? No.
It would be 10 square root of 2 minus XO squared, right?
it's going to be the following. Let me write it here.
Plus
Okay,
y
let's
squared.
write it separately and then we'll put it together. Yes, close to what you said. AO squared is going to be, all right, is this triangle. It's going to be y naught squared plus this point, say this distance. How much is this distance?
Then square root of 2 square the whole thing.
Not
No,
now.
It's 10 square root of
Diameter.
2 minus XO.
It's AB minus x naught. Do you agree?
Yes.
Okay, perfect. So in this case, it's gonna be AB minus x naught squared. How much is AB? 10 square root of 2. All right? 10 square root of 2 minus x naught squared. You see that? So that's what I'm putting here, square root of that. There. Also that is done with x naught and y naught, okay? F sub c, let's do cosine phi sub c. Cosine phi sub c. Okay, let's look at that. Now, I'll erase this. And is this triangle. See? How much is cosine phi sub c? And that is blue. that is gonna be this distance, okay, divided by this distance. You agree?
Yes,
Okay. How much is this distance?
5 minus y0.
Exactly. This distance is 5 minus y0. How much is this distance? Is OC. Let's write OC for a moment, okay? How much is OC squared? OC squared is this distance squared plus this distance squared. All right? So for a moment, let's remove, do that, remember where we are. For this moment, let's see how much is this distance that I have made thick, this one. This distance, you said it before, is 5 minus y0. So it's gonna be, sorry, 5 minus y0 squared. How much is this distance?
Wouldn't it be 10 root 2 minus, oh, sorry, it would be 5 root 2 minus x, so.
Exactly. All right. So OC then is gonna be this one. Therefore, cosine, this one cosine, phi c, is gonna be, here I will write it.
Wouldn't it be the first term minus the second term in the square root? Since this time we're trying to find one of the legs and not the hypotenuse of the triangle.
This is the diagonal of the triangle.
Oh, okay, I'm sorry.
That's okay. OC is the diagonal, so that's what we want to do. All right, so it's 5 minus y0 squared plus 5 square root of 2 minus x0 squared. Okay, so I got that. So now I have all of the cosines. This, remember, this, and this. All right, so I got the cosines out of the way. Now I need to find the magnitude of EB, EA, and EC. Okay, so magnitude of E, let's say B. EB. Not with square, without, okay. How much is that? The magnitude, now let's remember that the magnitude of EB, let's take this one. Is this one, okay, so I don't, the whole vector, I don't want to rewrite it. So then the magnitude of this vector is going to be this, which is QB over 4 pi epsilon naught, which is BO magnitude divided by BO magnitude cube, which makes it what? Do you agree?
Yes.
Okay, so now let us write it. EB, therefore magnitude is going to be equal QB. Well, we write it as QB. This is constant, the same. how much is BO magnitude squared? Here. BO is this. How much is that squared? We are now in this triangle. Let me see. How much is that? That's the easiest of all. That's the diagonal of this triangle. Therefore, it's going to be square root. Now, in fact, because it's the second power, but we'll write it like this. Okay, it's going to be, in fact, because it is in the second power. So it's going to be the diagonal of the triangle, which is x naught squared plus y naught squared. Do you agree about that?
Yes.
Okay, good. So now let's write magnitude of VA. Green. So then we have EA magnet, which is now QA 4 pi epsilon naught, and is, as we did with EB, directly 1 over AO squared. AO, the AO is part of this triangle. So how much is AO squared?
Y naught squared plus open paren 20 root 2, 10 root 2 minus XO squared.
So it's 1, so QA over 4 pi epsilon naught, because we have found it up here. You see that? We have found it before. So it's 1, and then y naught squared plus 10 square root of 2 minus naught squared. That. And then, same way, we go to EC, excuse me, which is QC over 4 pi epsilon naught, which is 1 over CO. Well, and CO, we have found it. You see it here? So this is going to be Q sub C, 4 pi epsilon naught, 1 over 5 minus y naught squared plus 5 square root of 2 minus x naught squared. Okay, so we got it. So now we are going to multiply cosine phi b with EB magnitude. So we're going to multiply these two. All right. So part C now. What we have? We have to write this equation, the sum of the three. So fact here, 2 becomes the following equation, cosine phi A EA plus cosine phi B EB plus cosine phi C EC equals 0. So that is equation 3. Right? And now we are trying to write equation 3. So we'll multiply cosine phi with with EB, and then we have QB 4 pi epsilon naught. And then it is Y naught. And then we have X naught squared plus Y naught squared to 3/2. Do you see that? Because we multiply the square root of X naught squared plus Y naught squared with X naught squared, Y naught squared. Do you see that? Do you understand why I'm doing this? Who has a problem with that one?
Can you please repeat?
Okay. So why did I write this one? This is nothing else but the following. Do you agree?
Yes.
Okay.
Mm,
Do you agree that I'm writing this one is the same way like writing it like this? Do you agree with that?
yes.
Okay. So now I can continue with the other ones and I can write the following. Let me see, let me go to cosine. Now EA, cosine phi A, so I'm times EA. So now I have the following. So I will do this is the cosine phi B EB. And then I will have cosine phi A EA is gonna be QA 4 pi epsilon naught. And in fact, here I made a mistake somewhere and nobody found it. So here is my problem. The mistake I've made is the following. I should have put here a negative sign. Why is that? Because it's obvious that EB and EA, their components along that direction will go along the positive Y, and for E sub C will go along the negative Y. You see that? We have to take that into consideration at this point. But if you were to do it, to plot their coordinates, like when you try to find, their Y components, which is what we've done, this one and this one, then you see why these two will be positive and this one is going to be negative. All right. Do you see that here? Why I changed the sign? Do you see why I changed the sign in this one?
Yeah, yes.
All right, that's important because if you don't change the sign, you're not going to find a solution. But we change the sign because it shows that they are opposite directions. And that's the only reason that you have a 0 in between. Because if you go any place outside like here, all of them will be along the same direction. And then of course, there is no way you can cancel out. See what I was saying? We were saying that, and that's also the thinking behind the team homework that I gave, all right? That's the thinking, that unless you are in between, in the space that define between the charges, you cannot cancel out the forces. So anyways, you need to remember that. So put the negative sign here because it is important. All right, so here I have also Y naught And I will have, for the same reasons, I will write it now faster. Let me see. Okay. And then I will have cosine phi c EC to be QC over 4 pi epsilon naught. And then here I have phi minus y naught, so I have 5 minus y naught. And then I have 5 minus y naught squared plus 5 square root of 2 minus x naught squared 3 over 2. Okay, and now I will put them in this equation 3. Equation 3. So finally, from 3, what do I have? I have the following. Q A and QB are equal, all right? So I will write here, I will sum this one with this one. So practically I have the following. Since QA and QB are identical, then I will write here and I have y not common to be the same. And then here I have 1 over x naught plus y naught squared, 3 over 2. And then I have plus 1 over y naught squared plus 10 square root of 2 minus x naught squared, 3 over 2. Okay. And I want this, I move this, because of the negative sign here in equation 3, I will move this term to the other side, this term to the other side. So I have, this is equal to QC, Q sub C, 4 pi epsilon naught, 5 minus y naught, and then it's 5 minus y naught squared plus 5 square root of 2 minus x naught squared, 3 over 2. And then, so that is canceling, and then QA is 5, QB is 5, QC is 2, I believe I gave as an example. Don't remember the exact, but finally we have the following equation. I will put here, since QA is 5 and QC, is it 2 or 3? I don't remember in the example that I gave. Let's assume 3. 2, okay, thank you. 2. So finally, we have here this equation. Y naught, everything in x naught and y naught. And then here, we have 1 over x naught squared plus y naught squared, 3 over 2, plus 1 over y naught squared plus 10 square root of 2 minus x naught squared, 3 over 2. You can make it equal or you can put the negative, it does not matter, equal to now, did I put 5 here, 5? 3, 5 minus y naught. And then I have 5 minus y naught squared plus 5 square root of 2 minus x naught squared 3 over 2. And that's it. And that is the expression you're going to try to solve or plot, if you like. Wherever that, if you plot it, wherever you find a 0, that is a solution of the problem. All right. Obviously, I'm not asking you to solve this. This is only the setup we did for the problem. Now, if I took a lot of time because I went through the triangles, all right, and the properties. However, if you were comfortable doing that, it will take much less time to solve this, all right? And the more you do that, but from this point on, you don't have to solve it. You can just write a small program where you vary x naught and y naught. And then you just find the point where this, in fact, goes to they're equal, or if you put it on the other side and you want to have this equation to solve, which is the original, put this equal to 0, you can find by plotting it what are the 0 points. So that is how you set up this problem.
Professor, I have a question.
Yes.
For the homework, you want us to give you the location of the point still, correct? That's like what you want out of it.
Yeah, I don't care about too many points or the full solution. I just wanted to see how you're going to set it up. And yeah, find the location of at least of 1 point if you can. If it's only one, that's fine with me.
Okay, and then as far as like graphing it for the part B,
Yes.
I've been having trouble like plotting that on MATLAB because I don't really understand how to do that.
Okay, so for plot B, what you could do, what I said in class, what kind of options do you have? What is it that you can do? Do you know how to set up the problem for part?
Real quick, I have a quick question.
Yes.
Why would it be 3 on the, or would it be 2 for the lower part of the boxed equation where you have 3 times?
Yes, 2. You told me 2, but I got stuck on 3. So I will correct it. Just a second. Yeah, I got stuck on 3. 2.
I also just had a quick question. Would it be 2 times 5 because you're counting for QA and QB? Or would it just be 5?
No, because I summed them up here. I summed these 2 are the contributions from each of the charges. If you do 2 times 5, is like you sum them up twice.
Oh, okay.
All
okay.
right.
Thank you.
So it would have been practically 1 5 here, otherwise, and 1 5 here. That would have been 1. That is the correct way to write it.
Okay, thank you.
And yes. So, for example, I was thinking what you can do if you know how to write small programs. Do you know how to write small programs? Do you know how to?
Yeah, yes.
You know some. I mean, I have to say, if you guys do not know how to write small programs, I don't know. That would be really tough for engineering, all right? But if you write a small program where you say, I mean, you know, I'm not writing a particular language, but yeah, you say you vary x from like x naught from 0 to 10 square root of 2, all right? And then you vary y naught from 0 to 5. And then you compute this expression, if this is like an f of x naught and y naught, So you compute x naught and y naught. And if x naught and if f of x naught and y naught is less or equal, put something 10 to minus 5, all right, depending, all right, you may be, the values you're going to find are going to be small, but let's assume 10 to minus 5, then you write the values of x naught and y naught, all right? Otherwise, you continue. I mean, this is such a small program that you guys should know how to do it, isn't it? That's all it is to it.
Could you also briefly go over kind of I'm just kind of confused on like what problem 2 is asking from us?
What I'm asking from you is to find the values x naught and y naught that make this one equal to 0. That's all that I'm asking.
Part 2?
For
Or
2,
2 with the equal potential lines?
oh no, that's a different story. I'm talking about this, about 1.
Oh,
Now, if you want to,
sorry.
yeah, we'll go to 2 next, but this is the one I'm talking about.
So you're talking about using a program to solve the problem for part 1A.
Yeah.
Okay.
This program, a small program that I would write, and then you solve the problem. That's all you do.
I think he was asking for part 1B about plotting, using MATLAB to plot the equipotential lines.
And that's the second part. Okay. Now it's a different, okay, so now that
Dr. Pitahi,
yes.
sorry, before we continue to part 2, I just wanted to ask you, because this process is different from the process you did on Wednesday, when we did it, instead of those forces, we did it with the force equations instead of electric field equations. And you also made a very good point that in this case, because the location of the charges are symmetrical and the magnitudes of each charge, A and B in this case, is both 5, then the horizontal components will cancel each other out. So we only need to analyze the symmetry axis where the charge would be. Why are we just assuming it could be anywhere if the horizontal components or the projections of the
Yes, because I'll tell you why you look at generally. So to tell you the truth, how I would solve it, all right? In the beginning, I would follow exactly what I did in class, all right? Because you look at every symmetry and you say, okay, most probably it's gonna be at the center line. That's a good argument. And then you solve the problem as I did in class, and then you try to find it on one line and you don't find a value. You don't find that anywhere on this line it goes to 0. So that's a problem, all right? So then you think, okay, if it's not going on this line, that is somewhere else, but I know it's somewhere, because in between the three charges, it has to go to 0 at some point, but it does not necessarily have to be on the line. It's just that the chances of being on the line are higher. Now, why is it that it's not on the symmetry line, of the line of symmetry? Because in this one is not only if the values of all of the charges were identical, it would have been on the symmetry line, on the line that splits the triangle into 2. But they're not the same, all right? From the moment that all of these 3 charges do not have the same value, same polarity, but not the same value, the distances in between them play a role. So the reason it's not in the midline here is because the distance between A and B is different here from what it was in the problem we solved in class. And obviously that difference in distance impacts the whole dynamic. And that's why it's not on the center line.
But the distance between A and B, you can partition it with the symmetry axis, and it'll be 5 square root of 2 on each side.
Now, if you partition it with the symmetry axis, then you can look only on the half of the triangle. I mean, your
Yes.
values here in the small equation, they're not gonna go all the way to 10 square root of 2, they can go to 5 square root of 2 here. So you will only do half of the triangle. In fact, you do more than half the way you do it here, because it's like brute force, all right? It's like you do a square. So practically, see what I
But
said?
I see what you're saying, but for the solution of the problem, can we just use the methodology you used on Wednesday, which is just analyzing the symmetry and then doing it with the force equations instead of the electric field equations?
You can do the force equations. It's not going to change anything because the charge is the same charge at the center. So you can start with force equations, obviously. The difference between the problem I did in class and the problem I did here is that if you follow exactly the same equation that I did in class with the appropriate changes, of course, in the dimensions, if you follow that, then you may not find the 0 on that line. And the reason you may not find the 0 on that line is because you change the dimensions. And it does not have to be only on, it does not have to be always at the center line. It depends on where the zeros will be. It will, all the values in between the Q's, the charges will be small, will be smaller than the values outside. You need to remember that. However, where it's going to be exactly 0, it does not only depend in the values of the charges, it depends on how different they are and how the distances between them are also there. So they may be, the chances of this, because they had some kind of symmetry, some symmetry, that it would be on the center line was high, but it does not have to be. For example, in the problem we solved in class, the distances between these two charges was different, was half of what it is here. All right, the charges were the same, but the distance was half. So in this case, it was like this. In our case, it's like that. All right, same charges, or even same charges, different positions. In this particular case, it was at the center. In this case, it's not in the center, it's going to be one here and one there. See? Off-centered. But it is at those off-centered points that it's going to happen. So the total field is going to go to 0 here, and it's going to go a little bit higher in here and higher outside. I don't know how to do it in 3D. It's going to be 2. For example, it will look like this. If this is 0, it will look like this between these points. I mean, if the field will go, and then if you go out of this, it will go higher. But it is at these 2 points. As in this case, in this one, it was going like that. Okay, it was the 0 was at the center and it was going higher up. See what I'm saying?
I think I understand what you're saying, but both of the triangles you just drew are symmetrical.
Yes.
In the distances.
They are symmetric along this direction.
Yes.
So both of them keep their symmetry. It's just that in this case, the null is here. In this case, there are 2 nulls, but they are symmetric. It will be, it's like an image and a mirror image. Half of this is going to be a mirror image of the other, but they're still symmetric. It's not like that the symmetry is damaged or something. It's just that the dimensions make it such so the 0 is not on the center line on this one. It's not on this. To be able to understand that, my advice is you have to set up the problem yourselves. You need to understand, this is the difficulty we are going to have in the beginning of this class. It's not going to be in trying to solve equations and blah, blah. all right? I'm not interested in this. It's like setting it up. And to be able to set the problem well, you have to understand what is happening. And you play a little bit with the forces, all right? This is a force like this. This is a force like that. This is a force like this, if they're all positive. In this case, in fact, if you had a problem more generic, like we did here, and you put this in the computer, and you allow in the computer to change also the dimensions between the charges, all right? So you keep the symmetry, but you change like the dimensions between A and B, then practically you can run this program and you will see how the electric field lines are developed. So, but even if you start thinking, like if you take the approach that I got here, but you do it yourselves and you think about the direction of the fields and what that really means, how I think that is going to help you a lot in trying to understand what happens eventually, even as you change the dimensions, all right? You just need to solve a problem like this, but they think more of, in physics, more about what happens when there are forces that go like this, what impacts these forces, what dimensions is the charge, but of course is the distance from its force, all right? And how eventually that cancels out with the two forces EA and EB cancel out with the third force EC. If you, even if you do this for a very simple case where all of the charges Q are identical and all of the dimensions, the distances between the charges are identical, even if you do that for the most simplistic case, then even for that, you're going to understand a lot more by doing that simpler problem and then extend it in something more generic. But what I would like you to do, that's what I want you, is you can make copies, and I will put those copies on the web, obviously. You can make copies of what I did. But try to understand, not so much, go through and then try to do the equation. Try to understand how I thought about the problem, the steps, part one, how I go to part two. What does that mean really? Why do I go to part three? How do I find the various components and sum them up? How do I calculate the cosines? All right. The how-to is more important to me than it is the particular math. Even if you make a mistake on how you set it up, the fact that you will know how to go from one step to another is very important. That's what I wanted to say in all of this. Do you want me to go to part B of that problem?
Professor,
Yep.
I was trying to access the recordings from earlier today that you sent on Canvas, and it seems like there's a passcode for each one.
There's not supposed to be a passcode. There is no passcode for it's everything. You click it and you see it.
I see passcode too, though.
You see passcode?
Yeah.
Yeah, I tried all like
Might be a
4 of them.
default setting.
Can I see? No, usually I don't require passcodes, but let me see, because it's on YouTube, it's public. I mean, if it's public on YouTube, everybody
Or
can.
did you? I was clicking on the Zoom link that you sent over.
The YouTube's visible. The Zoom links kind of weren't.
The
Okay,
links are screwed up.
Or they had passcode. The YouTube's didn't.
Yeah, the Zoom links work, but they require a passcode to access them. But I can just go to your YouTube channel if they're there as well.
You know what? Let me see. Now that you're saying that, I want to see what the heck is going on.
We basically only had Wednesday's class, or I think it might have been Mondays, and the how to do MATLAB video. And that was it.
You did the MATLAB, were you able to do it?
The 7-minute video, I was able to watch the 7-minute video, but not part B part, no. Or the second part of the homework.
That's kind of weird. Let me see. Okay, I don't know, what's happening, but let me try to do it. 1 second. I will, let me see.
When
No.
I just tried I went through like the Zoom Pro 13 on Canvas.
Oh, why do
And
you?
when I went in, I clicked one of the recordings and it said it copied the
No,
passcode to my clipboard.
No, you cannot. You don't do it like this.
Oh, okay, sorry.
Yes, I'm sorry. You don't go through the recordings because I only have access to those recordings, not you. What you do is you don't go through Canvas, but not through Zoom. So I will show you here. Let me see, let me do sharing. Where is sharing? Sharing. Oh, share screen. No, share. Okay, let me go to Howdy. 1 second. Do you see that? Do you see my screen or not?
Yes, we can see it.
Okay. I mean, which screen? Do you see the one where I'm doing Howdy?
We see your browser.
Oh, okay, good. Okay, so. Okay. All right, you go to Canvas. Okay. You go here. Okay, and then let me see. That. Oh, I'm sorry, they have also that to skip. Usually Zoom has.
Isn't that the old recording from class?
You wanted to do the one from Friday. That's the one from class. But you don't, what you were trying to do, you are telling me, okay, so now I understand what you're saying. Okay, so you are trying to tell me you were going to Zoom and then you were looking at trying to pick up the recordings.
For me, I went to my inbox where you sent us the link to the Zoom recording and I clicked on that link from Canvas. I can share my screen and show you.
Yeah, show me. Let me in fact stop this one. There is something running. 1 second. Okay. Yeah, you can share, let me see. All participants. Yeah, okay, go ahead. Let me stop sharing. 1 second. Would you like me to give an extension for a couple of days to this class, to this solution?
Yes, please.
That would be nice.
Okay. I will do it because it's the first time, all right? Yes,
you.
I will give because I want you to do it. I will send everyone a note. So when do you think a couple of days will help you?
Yes.
Okay. Let me see what I want is, show me, you can share.
Okay. So these are the links, all the individual links. If I click on this.
You cannot access those.
Right.
Yeah, because they are, okay, I'll tell you why you cannot access them. Because those links have, there are some of the office hours where there are people there and then individually talk about things. Those are not supposed to go public to the rest of the class. And usually it takes me time because even the ones I did on Friday, I have to remove every person as much as possible who either shows a picture like here, all right?
Right.
In the Zoom shows a lot of your pictures and names. So now that piece I have to remove. If I were to
Okay.
make it public, to available to class by university guidelines, and it takes time, you know, I have to edit primarily the whole Zoom. That's why I told a lot of people, record it yourselves if you want to have quick access to it. Otherwise, I'm liable if I don't do the editing. And I
Okay.
have people's names and voices and faces, you know, and then all of
Okay.
that becomes public because people can look at you and then can identify you, and then you can have weirdos sending you things on email.
So the links that are sent to our inboxes after each Zoom session are automatic and they're not for us to actually
Yes,
access?
yes, only I can access them.
Okay, could you post your notes from working through this example?
Yes. Those notes, as a matter of fact, I will post them right now. Okay, so we do it while you're here. Those notes I can do. Let me see. And I can do this right now, so you have access to it. Okay, so here. So usually what I do with these notes, I do a PDF, I email it to myself rather. Okay, and then it mails it automatically as a PDF. I sent it. And then after I get it, I go to the other one because I cannot do it easily from an iPad. So you can see, I'm gonna get it here. Usually they come my email. Let me do that and then we'll talk about the other one. There, I found that. So yeah, the Zooms, you're not gonna be able to have access to them, unfortunately. I mean, you know, there are good reasons for having to edit them. Okay, that is fine. Oh. Okay, and then I will put it on Canvas right now. And what do you normally want it? Should I put it under week 1, week 2 at the end? Examples. Okay, it is on Canvas and you should be able to find it. And let me know if you have any problems. It's under Wednesday, but I will probably include it on Friday. Should be there. And then I will show you about the, if you solve the first problem, doing the second part is easy. So text here, let me, 1 second. Right there. All right, for a moment here. All right, you see that in fact, okay, did you find it? Example from office hours, you should be able to have it available.
Yes, found it.
Okay, good. So now, the other thing that we want to do is do the second problem, all right? So it's easy on the basis of what we already have developed. So let me show you. So I'm gonna go here and share screen. Okay, part 2. What I will do for part 2 is I will open another file and that's not the, okay, so I need to change that. Okay. And then I will open it. So this is here. I need to open a new file and then that on the right. Okay, so now I have this because I will need some of these things and I will write on the left. So now what you have to remember is for, you have here a very general expression for the total field. Do you agree that this is nothing else? As a matter of fact, if you go here in this expression that we have from equation 1, all right, so I will say here find now. 1 second. Okay, find the potential and the relationship between the E field, the E total rather, in this problem, and the potential is this one. Okay? So, in XY coordinates, of course, we are going to find it on this XY and plane, where we have expressed all of the equations. So practically here we have that EX total equals minus theta B, theta X, and EY total is minus theta V, theta Y. Do you agree?
Does it change at all if we don't have that point charge in the middle? Because I think it just tells us to plot the lines of the 3 stationary charges.
No, it doesn't matter because if you write the E field, is like the E field is at a point where you put a charge. That is, these are all expressions for the E field, where you put a fictitious charge in that point, a fictitious positive charge. That's how we define the electric field. If, for example, you have a charge, see what I'm saying? How do we define the electric field? Let me go back. 1 second. Okay, how do you define the electric field? Who will tell me? You have a charge A, Q sub A, and I want to find the electric field at point B. How do we define the electric field? Who's gonna tell me?
It's the force, like the vector force at each point from that charge.
No, at point B.
Well, at point B would be a specific force vector you would have.
But that's force. How about the electric field? So I'll define that. To find force, you need two charges. All right, you cannot find force with one charge. Force applies on two charges, like you cannot have gravity with only one mass. You need to bring another mass there to see gravity. So force requires two charges. And if I wanted to find force to a charge Q from charge Q sub A, then that is on charge Q, and we'll write it as Q sub A times Q 4 pi epsilon naught, and then OB divided by OB to the third. Do you agree with that? That's force. What is the electric field? The electric field is what is the field that is generated by a charge. And we define at a point B, assuming that we were to bring a charge at point B, otherwise there is no force. So practically, if we bring a hypothetical charge at point B, if we bring a hypothetical charge at point B, which is Q, then there is going to be a force applied to it. And then we define the field as the force divided by Q. All right, that is the definition. And we found the electric field everywhere in this, all right, using that. And because we had the same charge everywhere, that's why you did not see that little Q, because practically it disappears from that anymore. When you look at electric force, we said that if the electric force is zero, in the electric field is zero, the force is zero, all right? So we only calculated the electric field. Because you always, when you try to find the field at some point, you assume that you bring a charge, the same charge, it does not change. Every other charge will see the same, but eventually you divide everything by this little charge. So it is no place to be found. Do you understand that? You need to think about this and understand it. Unless you really understand these concepts, you are not going to be able to solve any of the problems. All right? So that's what you have to do. Is that understood, therefore, what we were doing here?
So would that mean we'd be able to work for a negative charge the same way that we did as for a positive charge if it cancels out?
Exactly. Identical. I mean, it could be any charge Q. It does not have to be positive. It does not have to be. The only thing that it does is to change all of the directions. I mean, if it's positive, the directions are what I showed here. If it's negative, the directions will be in the other, but all of them will change. So the problem is going to be identical. See what I'm saying? So the polarity changes everything the same way of the charge. The value of the charge you bring at the center changes everything the same way. So at the end, the equations will be the same. Regardless, the equations of the 0 point is going to be the same regardless of whether it's positive or negative, and regardless of whether it was 1 coulomb, 2 coulombs, or 3, the charge that I brought. The same of 0 force, the location of 0 force is going to be the same. And please make a note to work it out and see that yourselves. Not just take my word for it, because if you don't work it out to see this yourselves, you have not understood the physics of the problem. And you're not going to be able to solve problems like that. I mean, if I change something small in this problem, you're not going to be able to solve it. All right. Any other questions before I continue? So practically, since I don't hear any other questions. So practically, I go here in this equation 1, all right, that I have. And that equation, practically, it gives me, at least for problem 1, it gives me the condition where the field is 0. Let me see. This gives me the condition where the total field is 0, but any place else, the total field is not going to be 0 at any other place. So the total field, practically total field, E X, E total, at any other place, is not going to be 0, but it's going to be the sum here impact. The total field is going to be this one. Well, let me write it. The total field, if I don't force it to be 0, eventually it's going to take this form. I will do it in EX and EY. So it's going to be EAX. See this one here, equation next to it. I use that, plus EBX plus ECX. EX plus EAY plus EBY plus ECY. EY. All right. Now, from here, what do I have? I have that minus theta b from here. This is, say, equation 4. This is from equation I got. Where did I put this? Yeah, here, from equation 2. From 2. Okay, so from 4 and 2, from 2 and 4, what do I find? The theta v over theta x is practically only the EAX plus EBX plus ECX. All right. And therefore, V from here, V will be minus EAX dx minus EBX dx minus ECX dx. And plus a constant, usually if you do that. All right, because if this is a constant that has nothing to do, it's a constant here, so if I do that, that means that and this is equation 5. If I differentiate 5, it takes me back to this one. All right, that's how we go from this down here. All right, so now if I know EX, let me do the first one first, because all of these will be very similar. Let me do this one first. And then what do I have? Let me find. So this is part 1 of this problem. So this is part 1. And then I'm going to part 2. Okay, and in part 2, what do I have? V equals minus. I'll do this one. Let me call this V1. I will call this V2, and I will call this V3. Okay, so V1 here, I will do them separately, so I don't carry all of the equations, dx. So how much is Z? Let me see it. How much is Z sub AX? I did all of the Y's. Okay, let's do the Y's first, because the other one is going to be identical. Y. All right, so we'll do the Y's first. All right, and that will be in terms of Y, since we have those. Y, Y, Y. Okay, and we do Y here. We'll start with this. A, Y, D, Y, C, Y. All right. So let's do this first. And that is Y. How much is EAY? EAY was cosine. So let me write here minus. Cosine phi A. Let me see decline. Okay, let me zoom. Share. Oh, do you see what I have? Okay. All right, so here, cosine phi. Okay. Okay, cosine. Wait a second. Let me let everybody know. One second. Okay. Cosine then phi sub A E sub A dy. All right, that's what I'm doing. Okay, so now I found it here, which is, all right, is this expression. You see it from here? This. So I'm writing it, and then I have minus QA, that's a constant, QA over 4 pi epsilon naught. And then I have Y. Instead of Y naught, I put Y, because now, of course, it's everywhere, all right? It's a general constant, Y squared plus 10 square root of 2 minus X squared 3 over 2. Okay. So now, and that's dy. So practically what I have here, this is a constant because it's only in terms of Y. So practically what I have is QA 4 pi epsilon naught. And then here I have Y dy. And practically I have Y squared and I will call this constant, this one, let me call it, what do you want me to call it? S, all right, plus S squared, 3/2. And this is a standard integral, which you can find everywhere, but I will derive it for you. This is going to be 1/2 dy squared. Do you understand why I write it like this? 1/y squared plus s squared 3/2. And then I will have equal minus q 4 pi epsilon naught 1/2. And then look at what I have. I now write the top as dy squared plus s squared because s is a constant. And then I have y squared plus s squared 3/2. I call this one t, and I call this one t. So practically I have the following integral, minus q over 4 pi epsilon naught 1/2. And then I have the integral of dt t 3/2, which is an integral you have to remember, minus q over 4 pi epsilon naught 1/2. And that, what does it give? It gives minus 1. It gives t, okay, let me see. That integral is 1/t 1/2, or is minus q over 4 pi epsilon naught 1/2, 1/square root of t. So practically, what you're going to find if you substitute back to this one at a time, you're going to find that this integral here is minus qa 4 pi epsilon naught 1/square root of y squared plus 10 square root of 2 minus x squared. And that's it. So that is one component. So you found, and then it's the reason you found that is because of this here, the derivations I've made. So practically you found that V1.
Aren't you missing the 2? The 1/2 multiply?
Yes, I missed that. So 8. Thank you. So practically you found from here that V1 is going to be minus QA over 8 pi epsilon naught. And then you have 1/square root y squared plus 10 square root of 2 minus x squared. So that's it. Now, if I follow the same, I can then skip all of this and find that V2, which is this, in the same way, without doing anything. I look at the, and EB2 is equal to BX, all right? Or to BY, in fact, because we looked at BYs. Let me clean this up a little bit. Let me clean this up. B, A, BY, B, let's see, Y. Okay. And then from here I can find the other ones. All right, so in this particular case, all of them will give me the same. So it's going to be, for V2, it's going to be QB over 8 pi epsilon naught, and it's going to be only in the denominator, only the denominator, but only with a square root. X squared, right? Plus y squared in this one. Only. And then V3 is going to be minus QC over 8 pi epsilon naught. And again, it's going to give me, maybe I need to take that a little further down. And it's going to give me 5, not 1, 1 over square root 5 minus y square root squared plus 5 square root of 2. That's for my example, all right? But you will have to do it for the problem. Just need to change some of the dimensions. And that's it. And then I sum the 3. I sum the 3, and that gives me the total V. The total V is going to be, 1 over minus 1 over 8 pi epsilon naught. And then you have 1 over square root of 2, y2. So in fact, you solve the first problem and the other is coming immediately. And then plus and then you have to plot that. Practically, you write a program, and I don't know how you plot. You know how to plot things. You can use a plotting subroutine, or you can go to MATLAB and do it in different ways. I'm open to everything. I don't have a particular. So let me see.
For the homework problem, will we need to find what the V is for the X component as well and plot that, or just for the Y?
It's going to be the same. It's going to be the same. X and Y will give you the same result.
Okay, so you just find one and then plot
Yes.
that and that.
Exactly.
Okay,
Yes.
thank you.
You're welcome. So that's it. And you plot that. Now, equipotential, what that means really is if you plot it, what I would do is, for example, I will give values and then I will have a small plot routine, and then I will, for example, you have, if you specify as you compute this, you do X, Y, for example, you do a do loop, all right? You do a do loop, so you plot X equals 0 to whatever, Y equals 0 to 5 in this problem, and in this is to 10 square root of 2. And then you have V, you calculate V, the value. And then I have if V equals, I give it a value, say for example, V U0, 1, then I'm recording those lines, I'm recording this on a vector. And if is V equals V0, 2, I'm recording on a different vector. And then I plot, so each one of these is a line. And then I go and eventually do a plotting subroutine, and I plot all of this line on an XY plane. See? And then here, where I plot all of this, so the X here, Y here, you will find different values. Practically, these X, Y values, they give you, each one of them, a point. So if you plot them all of this, it will give you different lines. So this one is going to give you one line, this one is going to give you another line. However you want to do it. I mean, it's a very small program you can write to do the plotting on XY if you want. Or you go to MATLAB and do it. You do the same thing, you calculate them, and then you plot the matrices, and they give you two different types of lines. But solving the problem is this one on the basis of the first one. Okay, so this is for, let me also upload this one. Okay, from example. To I will try to explain a little more. Any questions on that? How Aditi? Is that easy to see?
I think someone in the chat's asking if there's a mistake in integrating.
Where?
Something about shouldn't it be -2 divided by t to the -1/2 power.
Like,
Oh,
even
yes.
if I have, and it should be, yeah,
Yes, yes.
in the numerator should be 2.
It would be minus, first of all, because this is t2 minus 3/2. So it's a minus, it's d to t to minus 1/2. All right, so it's minus 1/2. Did I put only? So it's a minus sign. Plus another 1/2. It's 1/4. Am I right? Yes. Am I correct?
I thought we were talking more about the integral of dt over t to the 3/2.
Yes. Okay. So let me see.
For
What
that
is-
interval, you got 1/2 times 1/t to the 1/2. And we think it should be.
Okay, so the integral, let me do it quickly. Let me do it again. Just to see, because sometimes I cannot see it unless I do it. Okay, I'll do it without skipping stuff. So here we do have 1/2. 1, and then we have this. All right, so t to minus 1/2 d gives us minus 1/2 t minus 3/2. Do you agree?
Yes.
Okay, so t to minus 3/2 equals minus 2, yeah, d t minus 1/2. Okay, so let me move it also. Probably I did the constant wrong. So if this is correct, then this one becomes minus q 4 pi epsilon naught 1/2 minus 2 becomes the integral of d t minus 1/2. Okay, and this one okay, so here then we write, take this one here, this parenthesis. All right, so then that becomes q over 4 pi epsilon naught 1/√2t. Do you agree?
Yes.
Okay, thank you. Okay, thank you for that. All right, any other questions?
For the team assignment, do we just kind of put in words to answer?
As long as they are, there is meaning into that.
Okay.
Okay, I mean, there need to be, yes, it can be a written, but it has to be based on physics, all right?
Yeah. Okay.
Yeah. The updated due date is gonna be in 2 days, so Tuesday midnight. I saw a chat and I will change that, but before I do this, I need to also upload that. Okay. So the only thing I wanted to tell everybody is in electrostatics and magnetostatics, geometry is extremely important. And so we cannot just do this without using geometry. So please review those, review the fundamentals, all right? I mean, these are the tools. Our geometry is a tool, we have said it before. Integrals, be careful so you don't make the same silly mistakes I make when I write things on the board or here. As long as you look at what you do and then you check it again to make sure that there are no mistakes. Other than that, if you manage to use geometry easily, these problems in reality are not conceptually difficult, all right? And we are not going to see something more difficult than that for sure. But the setting up of the problem is what is important and not necessarily, you know, I don't care about the rest. You can plot it. Of course, it's important to see how the lines will go, but use whatever tools you have. Some people said that they were able to find for this problem the formula to solve it, which is fine with me. You know, if you find something, it's okay to use it as long as you understand what is happening. That's the whole thing behind this. So in any case, having said that, I don't know if I sent that already. Let me see. I do that already. I will upload it and I will do it immediately after I finish this office hours. Any other questions before